Santa Santa. Lightning Man is coming to visit you.
Ah, that is great news, Rudy. Hello, Elman, come in would you? Long time no see.
How is it going, SC?
Not so well, I am in a bit of a dilemma, finding a new way to estimate the number of presents we need before Christmas Eve.
Well, have you heard of the Chapman-Kolmogorov equations before? No, I haven't. How does it work? You can use the Chapman-Kolmogorov equation to derive the transition probabilities and probabilities of being in each state. You can even introduce an intermediate state, say, a small present for children who behaved well 1 out of 2 years.
This sounds quite interesting. Could you please explain it further to me?
Why certainly, SC. Perhaps you should take a seat. Let me see, where do I start? Do you know what a stochastic process is? Is it a random process? Ah, that's very good. Well, I think you should model the stochastic process with a Markov chain.
What is Markov?
Well, a Markov chain is a Markov process in which the state space and time set are discrete, and a stochastic process has the Markov property when the future states of the process can be predicted using only the present state.
Ah yes, the children move up or down one state depending on being good or bad this year from their current state.
Yes, correct. The transition diagram should look something like this. The children move up a state, if they are good that year, and down one state if they are bad. And, the Chapman-Kolmogorov relates to the transition probabilities in a Markov chain, which is the probability of moving from state I, at time m, to state j at time n. However, since I have introduced this new intermediate state k, it will equal the sum over each possible probability of going from state I, at time m, to state k, at time l, multiplied by the probability of going from state k, at time l, to state n, at time j.
Ah, so you have effectively split any path from I to j into 2 parts by introducing a fixed time?
Yes. However, I would suggest extending to the Markov jump process to get a better estimate of how many presents you will need. You can also use Markov jump process to estimate the probability of a good kid becoming bad and the minimum amount of time they will remain in the bad state.
What's the difference between the Markov jump and chain processes?
A Markov jump process is similar to the Markov chain discussed before, instead now it is a continuous time set instead of discrete time, but still with discrete state space. However, we no longer define transition probabilities as we do with Markov chains in discrete time. Instead we use transition rates or intensities. The Chapman-Kolmogorov equations used in the chain process become differential equations. We can use the forward equation to find the transition rate of a child leaving out of its current state, and the backward equation to find the rate of a child moving into a particular state. The transition rates are written matrix form as generator matrix with the sum of its row equals to 0.
Very well, but how do we apply this to my dilemma?
From the transition rates we can work out the holding times in each state, in particular the states of children receiving small and large presents that you are interested in. Holding time is the minimum length of time the process remains in the state. For example, length of time a child is in the good states for.
Wow. This was just what I needed to know in order to accurately estimate the number of presents that are needed before Christmas Eve. I can't thank you enough, Rudolph. Let's celebrate.
Thanks for watching. Bye.